Let's find a fundamental set of solutions for the differential equation 2t squared y double prime plus 3ty prime minus y equals 0. Given that y1 of t equals t to the negative 1 is a solution, we'll use the method of reduction of order. We are given that y1 of t equals t to the negative 1 is a solution. We'll look for a second linearly independent solution using reduction of order. We set y equals v of t times y1 of t, which is v of t times t to the negative 1. Now we compute the first derivative using the product rule. Y prime equals versus prime times t to the negative 1 minus v times t to the negative 2. For the second derivative, y double prime equals versus double prime times t to the negative 1 minus 2v prime times t to the negative 2 plus 2v times t to the negative 3. Now we substitute these expressions into the original differential equation and collect terms. After substitution, we simplify the equation. Notice that the coefficient of v becomes 0, which confirms our algebraic calculations are correct. We obtain the reduced equation, 2t times versus double prime minus versus prime equals 0. Let w equal versus prime. Then the equation becomes 2tw prime minus w equals 0, which is a first-order separable equation. We solve this separable equation for w. Separating variables and integrating gives w of t equals c times t to the 1/2. Now we integrate w to find versus of t equals 2/3 c times t to the 3/2 plus k. Therefore, y equals v of t times t to the negative 1 equals 2/3 c times t to the 1/2 plus k times t to the negative 1. The second term is a multiple of y1, so we can drop it. The first term gives us a new solution. y2 of t equals t to the 1/2. Let's verify that y1 and y2 form a fundamental set by computing their Wronskian. The Wronskian is 3/2 times t to the negative 3/2, which is never 0 for t greater than 0. Therefore, y1 and y2 form a fundamental set of solutions for the differential equation.